Hi everybody. Hi everybody. How are you? I apologize for being sick the last few weeks. I had both strains of the flu and pneumonia and a few other things. So I'm back home and I'll be back to see you on Monday. But I wanted to run by chapter on perfect competition. I know it's one of the more complex chapters. So I'm going to very quickly go over most of the highlights. We want to make sure we understand that the characteristics of this perfectly competitive market. There must be a large number of buyers and sellers. The products are homogeneous, meaning what one person sells is identical to what the other person sells. Any firm can enter or leave at any time, no restrictions, and everybody has equal information. It is important also to understand how the demand curve for the individual firm is determined. So we have the demand curve for the individual firm, whereas the demand curve and the supply curve. That carries over to the individual firm. So whatever price the industry sets carries over to the individual firm. And that's how each individual firm becomes a price taker. What people want to sell it for and what people are willing to pay for it determines the industry price, say per bushel, and then that carries over to the individual firm who has to accept that price. They are the individual price takers. How do they know when profit is maximized? There's two different methods. We can compare total revenue to total cost, which is on page 572 in your textbook, or we can also look at marginal revenue and marginal cost, which is at the bottom of that graph. What we're going to do is determine the short-run profit situation for the perfect competitor, a loss situation, and a break-even. There are three different steps we want to follow here every time. First thing we want to do, we'll set up our graph, is we want to, number one, draw the demand curve. We always want to draw the demand curve. Now remember, demand is equal to price, it's equal to average revenue, and it's also equal to marginal revenue. Because whatever price you're selling it at is the demand. It also is average revenue. So say it's $5, you're getting $5 a bushel. If you sell two at $5, you bring in $10. 10 divided by 2 is 5. If you sell another one for $5, now you have 15 divided by 3 is 5. So the price is equal to the demand, is also equal to average revenue. It's also equal to marginal revenue, because every time we sell one more, we're going to get $5 in this example. So the first thing we always do is we draw our demand curve, and it's always perfectly elastic. Second thing we're going to do is we're going to draw a marginal cost curve anywhere we want through the middle of it. Okay, so we have the price and then we have marginal cost coming up from the bottom. We now know two things. We know, number one, the quantity and the price. We know that they're going to stop producing where marginal revenue equals marginal cost, and we're going to go down to the quantity line. That is the total quantity that this perfect competitor is going to produce. We also know something else. We also know what total revenue would be, because he's going to charge this price from here up to the price line for each and every one of these. So this little rectangle at the bottom shows us our total revenue. So we now know the quantity that's going to be produced by the perfect competitor, and we also know the total revenue. But we don't know whether he's making any money. So in order to come to that conclusion, we have to add a third variable. We have to include what? We have to include the average total cost curve. So if we redraw it here, we have our demand, we have our marginal revenue, marginal cost I should say, and then we want to include the average total cost curve. We remember where our quantity is. We've already indicated the quantity where we're going to go marginal revenue equals marginal cost and go down. If we're in a profit situation, our average total cost curve has to intersect that quantity below the price. It has to be below the price. I know it's hard to see here, but you'll see that we drew the average total cost curve coming up, and it's now below the price, which tells us this is the average total cost to produce that quantity. Above it, as you can see, is the price he's charging. So if that's the price up here, and that's the average total cost down here, he's going to make a profit the distance from average total cost up to price and over to the quantity. So this entire rectangle above indicates the profit margin for a perfect competitor. So we did three things. We drew our demand curve. Number two, we drew our marginal cost curve. That tells us the quantity and the price. It also gives us total revenue. If we want to determine if this perfect competitor is making a profit, we also now have to include the average total cost curve. And that has to be crossing that quantity below the price. Okay? And the difference between what it cost them to make it and what they're charging, this rectangle above, is profit. If we were in a loss situation, we would do the same steps. We would put our demand curve. We would put our marginal cost curve. That tells us our quantity. That tells us our price. Now, if we're in a loss situation, the cost to make one more has to be greater than the price they're selling it for. So in this case, our average total cost curve has to cross that quantity at a price above, at a cost above what they're selling it for. So in this example, if this is the price they're selling it for, but notice the average total cost curve is actually above the price. And therefore, if they're getting this price here, but it cost them up to here to make it, they're losing the distance from price to average total cost above. And that is a loss situation, which is also indicated in your book. The last thing we're going to look at is a break-even situation, and we're going to do the same steps. We're going to draw our demand curve. We're going to do our marginal cost curve. That'll tell us our quantity. That'll tell us our price. Now, if it's breaking even, then obviously the average total cost to make one more has to equal the price they're selling it for. So in this example, we would want to go exactly where the price equals the quantity, and our average total cost curve would be touching the price at exactly that point. So the cost to make one more is exactly equal to the price they're getting when they sell one more, so they're now at a break-even situation. So it's very simple to draw profit, loss, and break-evens. We do the same thing for all of them. We draw our demand curve. We draw our marginal cost curve going up. That tells us the quantity they're going to stop at. That tells us the total revenue they're going to get. And the only thing that's left, we have to include the average total cost curve at that quantity of output. If it's a profit situation, the average total cost curve will intersect that quantity below the price. If it's a loss situation, we'll intersect above the price. And if it's a break-even situation, it'll intersect exactly at that price. And I'm going to take a second break here for a minute.